Thanks a lot for joining me for this talk about developing your CI tools. We have about 45 minutes, so I'll try to keep this entertaining, even though I'm not Chet or Romain. My name is Xavier Gouchet. I'm a senior software engineer at Datadog and team lead. These are our Twitter handles. And quick few word about Datadog. Datadog is an observability platform allowing you to track logs, status, performance metrics across your organizations and applications. We do offer over 450 different integrations, including Android, iOS, React Native, and coming soon, Flutter. So, before we start about talking about CI, quick word about the team. We're a very small team. In the Android SDK, we only have 3 engineers with lots of features, bug fixes, improvements, which means that we have a small bandwidth to do everything. And so we do have a CI setup. We have 2 CI providers, GitLab and Bitrise. We do most of our stuff in GitLab, and we use Bitrise mostly for every kind of operation that needs an emulator, because it's much more easier there. And what we try to do, because we have such a small bandwidth, is try to delegate as much as we can to the CI. The good thing about CI is that it's going to run automatically. Like whenever you push a PR, whenever you create a new branch, whenever you do a merge, whenever you do a tag, or just every time you do a new commit, you can have jobs that get triggered, and then they're going to run automatically. And from the CI, you can then have warning in Slack. You can have validation on a PR in GitHub or GitLab. So it's very useful. The very good advantage also on the CI is that it's going to be strict and thorough. It's going to be strict because it's computing. It's a computer, so there's no subtleties. If a warning is triggered, it is triggered. There's no, oh yes, but it's it's not really that bad. No, it is a warning. It's going to be strict, and it's going to follow the rules to the letter. And it's going to be thorough. It's not going to say, oh, this file is very small, or it's just a test file, so I don't need to look at it. No, it's going to look at all your files, even if it's a file that never changed in the last 2 years. It's still going to run through it. So with this, it's a very good way to offload all the tasks you have to do when you're doing PR review. There is this code review pyramid that was in a post by Gunnar Morling. It came out in March, which basically provides the vision of what you need to do, what you need to look at inside pull request reviewing. So the most important thing, and the one that you want to spend more time on, is going to be at the bottom, and at the top you're going to have things that are less important, and they can, you can let slide if it happens. So at the very, very bottom, you have the API semantics. We're building an SDK, so API semantics is very important. It's like what API we do offer, what the features are, how they're going to be used by our customers. Just above that, you have the implementations, which is the thing that most of people think of when they're thinking code review. They say, okay, I'm going to need to look at how things are implemented. Is the code performant? Does it work? Could it lead to crash? Could it lead to performance issue, infinite loops, you name it. So this is like the thing that you really, really need to look at. Then you have documentation. Documentation is very important, and it's very, very hard to do well. And documentation is actually, you have 2 folds for that. You have the documentation, of course, for the people who are going to be using what you're building. So it's either the documentation of your application or the documentation of a library, if it's a library. So people that are going to be using your code need to have some documentation to understand what they need to do. But you also have documentation about the code itself, because more often than not, you're going to be in a team with other people, other developers, and you need to make sure that people that go into your code during the review, but also at a later time, because they're going to be maintaining your code, they understand what you are actually doing inside of it. So documentation is also all the comments that you're going to leave to the code. It's all the naming that you're going to have for your classes and methods. Then you're going to have the tests. Tests are very important. I'm going to come back to this, but tests are very, very important. And then you're going to have the code style, which is basically deciding whether or not you're going to leave a blank space between two methods, if you want to have your curly brackets in a new line or at the end of the previous one, if you want to leave two spaces between commas, you name it. And this is much more of a preference thing. It's like you're going to say, oh, I prefer to have my commas like this, or yeah. And the good thing is that in the CI, we're already used to delegate some of those things to the CI itself. So when we write the tests, we let the test be ran by the CI. And I think most of you, when you have your CI set up, the tests are run automatically. You don't have to actually run, check out the pull request and run the tests on your local machine. And for the code style, we have a lot of tools like Kotlin for Kotlin, and we have like PMD and check style for Java code to make sure that we follow some standards. But we can also use the CI to run some work to check the documentations, the implementation, and the API semantics. And this is what we're going to be talking about today. So first we're going to look at Detekt. Quick show of hands, who in the room is using Detekt in their professional or personal projects? Cool. So for those of you who don't know, Detekt is a Kotlin static analysis tool. Static analysis means that it's going to take a look at all your source code files. It's not going to run them. It's just going to look at the tree of the files, and it's going to try to find anything that looks fishy. It's going to look at code smells, performance issues, code complexity. It can tell you if there is documentation missing, and there's a lot of other things that it can do. So it can say, yeah, I'm going to just take a look at the source code, and I can already point at some things that seems wrong. And the good thing is that you have hundreds of rules now in Detekt, so you can sit down with your team and say, okay, this rule we want to have applied to our code base. This rule, we don't really care about it because we disagree with the owner, so we say, oh yeah, it's not that important of a rule. And when you run Detekt on your project, you're going to have something that looks like this. You're going to have, some bunch of metrics and complexity reports, and then you're going to have all your warnings line by line that say, hey, in this file at this line, you have, like, for instance, here a function with an empty block. Well, if it's an empty block, you can remove it because you don't need to override it, and that way you can have those treated as warning or errors, and in your CI, basically, you can say whenever there is a warning, or if the number of warnings is above the threshold, you can fail the pull request. So how does it work exactly? Detekt works with a visitor pattern over the syntax tree. So the syntax tree, you all know what a tree is. You have nodes that are going to represent the syntax of your code. So you're going to have a node that says, oh, I'm a class, and underneath it you're going to have a node that says I'm a function, and then underneath it you're going to have a node that says I'm a statement, or I'm an if block, and so on. And the syntax tree that is used by Detekt is the PSI, so it's the program structure interface, which is the syntax tree that's been created by JetBrains for all the IDEs. So if you're using Android Studio or IntelliJ, whenever you have a source file that's opened, it's going to be using PSI under the hood to manipulate the code around. And Detekt can also have type resolution. So when I'm saying it's just looking at the source code of your file, it's actually using the Kotlin compiler to know that, oh, I'm referencing a class that's in another file. Well, I actually know about what methods are available in that other class files. And then you're going to visit those patterns, so you can visit every node in the tree for every source file that you have, and you're going to try to find a specific pattern and report issues when you find them. So as I mentioned, you have hundreds of existing rules, but you can also write your own. So if you want to write your own rule, this is the kind of class that you're going to have to write. It's my custom rule, or you name it, like what you want to detect. You have one one property to override, which is the issue property, which is basically just a definition of what issue you're going to be reporting. First, you're going to need a name. Usually, you want to use the name of the class because it's easier to keep in your mind. Then you're going to have a severity. You're going to say, oh, this issue, it's just a code smell, so it's not complicated, or it's a performance issue, or it's a potential bug. So you can, say if the issue is very important or not. Of course, you want to have a documentation, so you have a description of what the issue is. It's a free string, you can put whatever you want in it. And you have an estimation of how long it would take to fix this issue. So if this issue is reported, the report is going to say, oh, by the way, if you want to fix it, it's going to be 5 minutes, it's going to be 20 minutes, it's going to be an hour, or it's going to be a week. And then you have a lot of those visits star expressions. So you have visit expression, which is one of the most useful one, because 90% of the nodes in the PSI are expressions, where you can say, okay, I'm visiting an expression, but you also have a visit function, visit type, visit try catch, visit import, visit package declaration, and so on. And in this, the algorithm is always going to be the same. You're going to have a method that you're going to write, which is going to say, is it an invalid expression? So you look at the expression, you look at the tree, at the nodes, at whatever is in it, and you say, is it matching the pattern that I'm looking for? If it is, you're going to call the report method with a cut smell or another class that says, hey, I found something, write this in the report. And so in this, you're going to pass your issue that you declared earlier. You're going to create this entity from expression, which is going to help the report to say, this is in this source file at this line, and it's going to highlight it and say, hey, this is the part that you want to fix. And you can add a specific message to say, oh, by the way, the issue is with the name of the property, or is with the import statement, or you can be a bit more precise than just the description of the issue. In our code base, we have a lot of custom rules in Detekt. Some of those are to make sure that we're never going to crash in the application that use our library. So we're writing an SDK, applications are going to use it. The last thing that we want is have a crash in their application that is caused by our library. So the three first rules that we wrote is making sure that we don't throw an exception, that we don't use the check or require methods in Kotlin, which do throw an exception internally, and that we don't use the double bang, which is going to throw a null pointer exception. I understand this, but basically, if you have a nullable type, deal with the nullability all the time. But we also have some other safety method. One of them is having a flight to find unsafe third parties. So in the library, we're using the Android frameworks. We're using some Jetpack libraries. We're using OKHTTP. We're using some other third-party libraries. And some of those are written in Java. And some of those are written in Kotlin, meaning that some of those might throw exceptions, IO exceptions or illegal state exceptions, or you name it. What we did is go through the source code of all those libraries and say, oh, when I'm calling this method, it could throw this exception. And we have a file in Detekt that says, okay, I have a matching and say which methods are actually unsafe. And then we know that we made a rule that says if you're calling one of those methods and you're not in a try-catch block and you're not catching the exception that could be thrown, you're going to have a warning. So basically, this is like the checked exception that exists in Java. We're applying it to Kotlin as well. and this makes sure that we're never going to crash something from a library that we're calling. The last one is not a safety thing, is more a workflow thing. When you're writing your feature and you say, oh, at some point I would like to change this or I need to implement something else, you have a to-do comment in your code. Just to make sure that we never forget about those to-dos, we make sure that in this to-do command line, you must have a Jira ticket reference, meaning that we do have a ticket in our backlog in Jira that says, oh, by the way, we need to do this eventually. This is going to be an enhancement or like an improvement on the code base, and it's going to show up in our backlog, and eventually in a sprint, when we have the time, we're going to pull it and work on it. Meaning that every to-do command that we have has a Jira that is associated with it. If you want to go further, you can even make the rules configurable from detekt.yaml. So everyone who uses Detekt know that you have a YAML file where you can say, oh, I'm activating this rule, but you can also say, oh, by the way, I want to increase or lower the threshold. Like when you say, for instance, how many arguments can I have in a function signature until it becomes a too many arguments issue, you can increase this threshold. If you want to have your rules configurable in your custom rules, you can do that like this. So when you create your rule, you're going to have first a config argument, which is like a class that comes from Detekt, and then you can have your property that uses delegate, which is by configured with an optional default value. And then the name of the parameter in your config file, in your YAML file, is going to be the name of the property. And then, like, it's very easy to set up, and so you can have booleans, integers, strings, even lists. So it's very easy to use. If you want to have more info on Detekt, you have the official Detekt website, you have the open source Detekt repository. It's open source, so all the rules are available out there. You can dig through them. So if you want to say, oh, I really like this rule, but I want to change the way it's working, you can also have the source code for all the official rules in Detekt. And there is a podcast called The Developers Bakery, and in episode 30, they had all the maintainers of the Detekt project come to talk a bit more about the internals and how Detekt works, and also about the future of Detekt. So it's a very, very interesting episode. Go listen to it. So the next one I want to talk about is the Kotlin symbol processor. Again, quick show of hands, who knows about KSP and who's using it? Okay, very few people. You're in the right place. So what is KSP? The Kotlin symbol processor, it's a lightweight compiler plugin that's embedded in Kotlin, which is very similar to APT and KPT. So APT, if you've been working in Java, it's the annotation processor tool, which allows you to say, I'm detecting some classes or some methods that have a specific annotation, and I can read them at compile time and do something about them. KPT was the first thing that Kotlin did to match this, which is Kotlin Annotation Processing Tool that uses the APT APIs, but it's still within the Java world. KSP is making it part of the actual Kotlin compiling experience, meaning that it's closer and it's also better embedded for Kotlin multi-platform. And so what is KSP? It's basically going to help you to read the source code and allow you to generate some new classes or new files at compile time. So how it's going to work is that you're going to have a processor, your class, that can query files or declarations from your source code, and then you can generate new code, but you cannot modify existing one. So it's always, I'm going to generate a new file that's going to do something new. So you can write a custom processor that's going to class this. So you can make my custom symbol processor or any name that you want. That's going to have a code generator class instance. This class is basically already built in your compiler, so it knows where it's going to put files if you want to generate new files. So it's going to be in Gradle, it's going to be in the output/generated/ KSP folder, and you're going to have a logger that allows you to write stuff in the console logs during the compilation. So if you want to print warnings or print information when you're running the Gradle task that's going to compile your application, you're going to have those logs appear there. And then you just have to override this process method, which has a resolver and returns a list of annotated elements. We're going to look a bit more about that later. So this process method, at first, so what it returns is basically a list of different elements. So what you have is your method process is called once, and you're going to have access to the whole source code that is being compiled right now. And the thing is that maybe you don't have all the information yet to do the work you want. So what you can do is create this deferred list of annotated elements and put elements into them. And this is going to be your return value for this process method. And if you return a non-empty list, basically your process method is going to be called again for you to treat those deferred elements. So basically you may have 2 passes or 3 passes or 4 passes, or as much as you want, where you need to iterate, and you can say, oh, by the way, I need to be called again to do something additional based on what I generated. So one of the easiest things, the resolver is basically your access to the code base. So you can just say, okay, give me all the files, or give me all the declared type, or this one, which is very useful, is get symbols with annotation. So you're going to say, okay, I have a com.example.myAnnotation annotation. I want all the symbols that are annotated with it. So maybe it's going to be classes or interface that have this annotation, or functions, properties, like anything that you can add an annotation on in Kotlin. It's going to return you a sequence, and for each of those you can say, okay, I'm going to try to generate something with it, and if I can't, I'm going to put it in the deferred list, for instance. And the generate something is basically you have access to this, again, you're going to have access to a syntax tree of this type or the source file. You can look things through it, and then you can generate a new file thanks to the code generator. And as I mentioned, again, you return the deferred list to say, hey, by the way, I need to be called again, or an empty list if you know that, yeah, I've done all my work. An example of a custom processor that we do use in Datadog is this generation of a no-op implementation of annotated interface. As you know, we could have nullable variable types, not variable properties in our Kotlin. The thing is that dealing with nullables, especially for vars, can be a bit verbose and a bit, tedious. So what we have instead is we have not always non-nullable variables that are typed as interfaces, and what we say is by default they're going to be using a no-op implementation, which is basically an implementation of the interface that does nothing. And so you can have an interface that's written like this with the @no-op implementation, where we say, okay, basically I want the KSP to generate a class that implements this interface but does nothing. I won't go into the details of the implementation, like it's very straightforward, but basically what it's going to do is it's going to create this class that implements the interface, and it's going to say, well, I'm going to implement it, but I'm doing nothing. Then you must say, oh yeah, but what if I'm returning something from my interface? So for instance, this interface that says, hey, I'm a reader, so I read things, I return something, so I'm returning a nullable. Well, or KSP processor is going to say, well, if it's nullable, I'm going to return null. Of course, it can get a little bit trickier than this, because if you want to return non-nullable type, we have a lot of other things to do. There are some interfaces that we have that are providers, which means that the implementation is just, I'm returning an interface, and basically we can say, oh, if it's returning an interface, I'm going to return the no-op implementation of this interface, and so on. And if it's numbers or strings, it's very easy to say, oh, the default value is going to be 0 at the empty string, and you're quite okay with that. If you want to go further into this, there is the Kotlin Poet library. Kotlin Poet, so first there was Java Poet. Kotlin Poet is basically the same thing as Java Poet. It's a library that allows you to easily generate Kotlin source code. So for instance, we have this very small Hello World Kotlin Poet code, where basically we just say, okay, I want to write a Kotlin file. So it's a file space builder. The file is going to be greeter, so greeter.kt. I didn't put any package name because it's easier that way. In this file, I'm going to add a type. The type is going to be a class that's going to be named greeter, and in this class I'm going to add a function which is going to be called greet, which takes a string parameter which is called name, and it's only going to have a statement which is equal to println with hello and the name of the that's passed in parameter. And basically if you run that and you print the output of this, you get this Kotlin file. So this is something very, very useful to use when you're using Kotlin symbol processor, because it allows you to very easily generate your Kotlin source file without dealing with the actual syntax of saying, okay, I need to put indentation, so I need to add four spaces. Oh, but no, because I'm in an if statement, so I need to have 6 spaces, or maybe 8, or like. It's very tedious. Kotlin Poet does all this for you. It handles all the imports for you, so it's very, very useful. If you want to have more information, if you want to dig into KSP, you have, of course, the KSP overview on the Kotlin Lang website. You have the GitHub repository that's maintained by Google. And also you have the Kotlin Poet library, which is written and maintained by Square. The third thing that we do use is custom Gradle plugin. Again, show of hand, who has already wrote a custom Gradle plugin in their project? Cool. Gradle plugin, basically, so you all know Gradle, hopefully. If someone doesn't know about Gradle, let me know. No? Okay, cool. Gradle, so you all know how Gradle works. Gradle is basically where you're going to declare your modules and projects, your dependencies, and all the tasks that run with it. And with Gradle, you can create custom tasks that can allow you to do compile checks, or code generation, or anything, helper classes. So the way Gradle works, when you're calling and you say, oh, I want to run a Gradle test, basically there's going to be a specific JVM that's going to be spawned, or it's going to be reused if you have the daemon, which exists by default. There's going to be an empty project object that's created by Gradle, and then it's going to read all the content of your build.gradle or build.gradle.kts file, and it's going to apply the plugins that are going to add extensions and tasks to it, and then it's going to read all the extensions. So the extensions is basically when you say and read curly brackets, like with a block, this is an extension that's added by the Android plugin. When you have Kotlin and a block, it's something that's added by the Kotlin plugin, and so on. You know what I mean. So if you want to create a custom task, which is something that can be run, and so you can have it appear in your list of tasks or in the command line, basically you can just say, okay, you inherit from the default task. One other thing that's very important to do is to, in the init block of your custom task, set the group and description. The group is basically how all the tasks are going to be grouped and available. So when you look at the side panel with all of the Gradle tasks, you know that there's one for Android, there is a build, code verification, tests, and there is one that's called other, and by default when you create a new task it's only going to be in other. And because other is where everything is put, it's very hard to find a task in this. So usually if you create your own group with my company, it's going to be easy to find all your custom tasks. Or if you want to fit into one of the existing groups, you can also do that. And writing the description means that whenever you look at the tasks, you're going to have a tooltip that says, hey, by the way, this is what this task does. Or when you list all the tasks in the command line, it's going to be also explained there. And the only thing you have to do when you write a task is to have a method. You can name it however you want, and you just have this annotation task action, which is how Gradle finds what the task actually does. And basically in this you can have literally whatever you want. Once you have your task, you can also create a custom extension, which is basically just a class. So not a data class because it needs to be open, so it's easier to do it like this, where you can have some arguments that can help you modify how the tasks are going to work. So you can say, oh, by the way, I need to have an output file, which is going to be of type file with a default value, and maybe I want to enable some feature in my tasks, so it's going to be a boolean, which is going to be false by default, and you can have a threshold as an int, you can have some custom naming as strings, like whatever you want. And finally, to tie it all together, you can write a custom plugin, which is going to be extend the plugin class, and then you just need to override the apply method, which takes the project. So the empty project that's created by Gradle at the beginning of the run is going to be passed into your plugin, and there you can say, okay, on this project that you give me, I'm going to create a new extension, which is going to be implemented by my custom extension class, and it's going to be named my extension. And my extension is basically the name that you're going to have. So for Android, it's going to be just Android or Kotlin. So people are going to be able to say my extension block and specify all the parameters for your extension. Likewise, you can create a task that's going to be implemented by my custom task. The name is going to be my task. And this is like the task that you're going to be able to run either from the command line or from the Gradle side panel. And finally, you can link the extension with the task. So you create a property in the task that says, oh, by the way, I have access to an extension. You link those together so that when the task is actually being called, it can read the value from the extension. So a few examples of what you can do with custom Gradle tasks. One of the things that we do is to compute the dependencies that we have. So we're, as I mentioned earlier, we're using some Jetpack libraries, we're using OKHTTP, we're using some other stuff as well. So one of the things that we want to know is, say, when someone pulls in our SDK in their application, what's the total amount of libraries that they're going to be pulling in transitively. So we know the size of our SDK, of course, and we have this thing that say, okay, if you don't have anything that we provide, all the libraries, all added all together, amount to 500 megs or 550 megs or whatever. Also, we have this a tool that looks at all our dependencies as well and look at the license, the open source license that are used. Because basically, we're open source as well, and some open source licenses are less friendly than others, meaning that some open source licenses have some requirements that if you're an open source project that uses them, you need to do X or Y. So we have this to make sure that we know and we review every library that we use. And so this one is basically we're taking use of the dependencies that are declared in Gradle, and we say, okay, for all our dependencies, we're going to look in Maven, what's the size of the artifact, and we go and look in Maven as well. We have the name of the open source license, and we know what the copyrights are. Second one that we have is keeping track of the API surface. When you're writing a library, you want to make sure that when you publish a new version, you're not breaking changes. So you're not, if people upgrade from version 1.8 to version 1.9, you don't want them to have to go over all their code base to say, oh, by the way, this method add a new argument. So you have to review everything you have already. So we have, basically, we're generating kind of this surface. It's like in Android Studio or IDE, you have a panel that's called the structure of your file, and basically we just extract the public information that's this. So every public class, every public function, every public property is being displayed in this API surface file. And so we know whenever we change something in this file. So it appears, because it's part of the compile process, it's part also of the changes when we do a commit or a pull request. Last but not least, we have also some code generation that's being done from the JSON schema. So we do exchange a lot with a backend, and basically we have a JSON schema that says this is the type of data that the backend accepts when we do a post. So we need to make sure that, yes, we need to conform to the specification. And so we have a thing that says, okay, it's a JSON schema, we're going to generate the data class, the Kotlin data class out of it. And so basically we're pulling the JSON schema from a shared Git repository, and we're going to generate the data class with Kotlin Poet again. If you want to go further with this, you can even link tasks together, and this is very useful to do because, for instance, you want to say, oh, whenever I compile my project, whenever there is some compilation, I need my my custom task to be run before. So for instance, so you could do this easily in your plugin where you say, okay, I'm going to find all the tasks that have the Kotlin compile type, and I'm going to make them depend on my custom task. What this is going to do is basically, the way we use it is for the JSON schema thing. So we pull some JSON schema, we generate some data class, and we say, okay, whenever I make a compilation, I need to make sure that my data class are updated before the Kotlin compile, because otherwise, basically, it might be absent, and Kotlin is going to complain that, hey, you're referencing this class, but it doesn't exist yet. If you want more info about that, you have, of course, the official Gradle documentation, which is very useful. But a few years ago, I did a talk in Mobile Era in Oslo where I spoke in detail about writing custom Gradle plugin. Most of the content is still available. It's still relevant today. So there is the YouTube link and the slides that are available online. Finally, I'm going to have a quick talk about Kotlin compiler plugin, which is basically, as you know, something that you can add to the Kotlin compiler. So you all know Kotlin, obviously. And a Kotlin compiler plugin gets access to either the Kotlin source code or the IR, which is the internal representation of the code once Kotlin did analyze the source code. And from this, you can manipulate whatever you want. You can manipulate the actual source code before it's being compiled. You can manipulate the IR before it's being translated into JVM bytecode or JS or whatever you want. And the way it works is very similar to aspect-oriented programming, meaning that you have lots of classes and you want to add bits of code in specific places. The way the name of this is called code weaving. So basically, you're just weaving your specific code into all the classes. So it's going to look like something like this. You're going to say, oh, I want to have some bits of code that's added whenever I'm finding this specific pattern. I'm going to add a little code. This is actually what's being used by Jetpack Compose. They have their own compiler plugin that's going to add something around your composable methods. The way the compiler works, very briefly, is you have your source code that is going to be parsed into an abstract syntax tree. Again, this is the PSI that JetBrains uses. You're going to have some analysis and resolution, which is basically just saying, okay, I'm referencing a different class that's declared in another file. It's going to find those from the package names and say, yeah, actually, you're calling a method that exists. It's the right number of arguments, the right types, and so on. And eventually, you get to this IR, internal representation of, so it's still a syntax tree, but it's specific to Kotlin, meaning that it's the most Kotlin syntax tree that you can have. And the last step is, depending on which target you're using Kotlin for, is going to generate JVM bytecode, JavaScript, or native code. So with the compiler plugin, you need three things. You have, of course, the compiler plugin itself, but you also might need a Gradle plugin or Maven plugin, because you need to make it easy for people to say to the compiler, oh, by the way, add this plugin. You can do this by hand, but no one actually calls a Kotlin compiler by hand. You use just a Gradle task that does it for you. And on top of that, you might want to also have an IDE plugin, so Android Studio or IntelliJ plugin, that's going to add some little icons in the source code. So if you've been using Jetpack Compose, or if you've been using coroutines, you will have seen those little symbols that are part of the IDE that say, oh, by the way, this is a coroutine method, or by the way, this is a composable method, so I can have a preview. This is done by a specific plugin. So I mentioned Jetpack Compose already, which does a lot of stuff around your composable methods, but you also have an official Kotlin compiler plugin, which is open, that makes all classes open by default. As you know, in Kotlin, all classes are private by default, so in some backend work, you want to have all your classes open, and this compiler basically just switches this for you. If you want more info about this, you can go watch. There is a YouTube talk from a Kotlin conference that explains how you write a compiler plugin, the Gradle plugin, and so on. But you also have Arrow, that you might know if you do functional programming with Kotlin, which are also providing a functional way of writing Kotlin compiler plugin. So they have the full documentation and they have a Medium article on how to do this. Very quickly, a few more information about all of this. I mentioned PSI a few times, which is the abstract syntax tree that JetBrains uses, that is used by the Kotlin compiler, that's being used by the Detekt, and so on. There is an IDE plugin that works both for IntelliJ and Android Studio, which displays the actual PSI for the source file that is actually open. So basically, if you have an open source file that's in a tab, you can have a side panel that says, hey, by the way, this is the syntax tree that we use to represent this. And because they are linked, you can actually say, oh, what I'm interested in is this call to this method, or it's this if statement, or it's this try-catch block. And you're going to see exactly what it looks like internally, meaning that it's going to help you write your Detekt custom plugin or your Kotlin compiler plugin. Just in conclusion, so there are lots of tools that you can use to enhance and do a lot of stuff to you that you used to do manually that you can use in your CI. Just remember that if you're writing Detekt rules, Kotlin symbol processors, Gradle scripts, Kotlin compiler plugins, and so on, it's still code, meaning that you need to keep them as clean and maintainable and trustworthy as your production code. You also need to write tests on them. You have, if you don't write tests, or if you think you don't write enough tests, there is a session about testing UI in this room just after this talk. There is a session about testing coroutines in Mobius this afternoon, and tomorrow I have a workshop about property-based testing. Useful links, if you're interested in what we talked about, and if you're interested in about our own custom rules, you can look at our project, which is open source, so you can see how we implemented some of the examples that I mentioned here. And I don't think we have time for questions, but I am in the office hour just after that in the first floor. So thank you very much. Any question?
So I have a question about analyzing your code. I saw that you talked a lot about Detekt, but you don't talk at all about lint, and especially lint rules. From what I saw, it's pretty similar to define Detekt rules and custom lint rules. So what is your advice about when to try to write custom lint rules and when to try to write custom Detekt rules? And is there any big difference between the two?
Are you talking about Kotlin or the Android lint tools?
Android lint.
Android lint. Basically, I think it's a matter of preference. Basically, anything you can do in one, you can do it in the other. In my experience, Detekt is much easier to use because I'm easier because I'm more used to it. Basically, if you already know how to use to write custom Android lint rules, I think you can do most of what you could do in Detekt. It's just complementary. Basically, both of them can be run in the CI, so it's the same kind of rules, and I just think it's a matter of preference from one to the other. I know that I usually prefer Detekt because I'm used to sometimes writing Kotlin code that's not necessarily for Android, meaning that Detekt is Kotlin specific and not Android specific, and Android lint obviously is Android specific. Any other question? Yeah.
I wanted to ask you about how do you deal with your code coverage, unit test coverage in the CI?
So that's a good question. So we do have some tools to report our code coverage and have metrics about it. So my personal view on code coverage is that it's an indication, but that's not a those things are tested. So when you have, like, let's say a code coverage of 80%, it doesn't say that 80% of your code is tested. It says that at least 20% of your code is not tested yet. So for me, code coverage is an indication that says, hey, these are the classes, these are the methods that you need to look into because those are not tested yet. The code coverage for me, like, it's an indication, but it should not be treated as, oh yes, those classes are safe just because they're covered. Code coverage, I mean, at least unit test coverage, the way code coverage works is simply saying, during your tests, at some point, there was one call to this line. It doesn't mean that this was followed by an assertion, which is the point of a test. So if this is called, but there's no way a test would fail after it's been called, it's covered, but it's not tested. So for me, I look at code coverage in a sense that guides me and say, oh, look there because you don't test this yet. But I try to always keep in my mind that, yes, it's covered, doesn't mean it's tested. So usually I always double check and say, okay, is it really tested? If you're really interested into that, there is a bit out of scope here, but there is this paradigm that's called mutation testing. I did talk about it a while ago, and there was an episode in Android Leaks, which is the French podcast about Android. I think most of you know this, hopefully. But basically, mutation testing is something that runs your test against mutation of your production code. So basically, it introduces flaws in your production code, runs the test again, and makes sure that, okay, yes, there is a test that detected this flaw, meaning that you actually are testing this. Yeah, I think we're out of time. Thanks a lot again for listening to me. And again, I have office hours starting in 5 minutes in the first floor next to the snacks. Thanks a lot.